Okay, let me give you one more problem, okay? Here we go. So this one is also, we can use the, undetermined coefficient method variation, coefficient method, like whatever, okay, we can do it, okay? But let me show you how we can solve this one by the Laplace transform as well, okay? So let me apply the Laplace transform for this differential equation. Then this can be written by Laplace transform of y double prime minus 2 y prime to y, and right hand side, well, in the previous problem it was homogeneous, okay, but this is non-homogeneous, okay, but it is same process, okay, but only thing is you gotta have something on your right hand side at the beginning, okay, like that, okay. So we're going to do lifting for your left hand side, and we're going to find the Laplace transform of the exponential function on the right hand side, okay. So let me write directly, okay, it is s squared ys minus s times y0 minus y prime 0. The second one, minus 2 times s ys minus y0, and plus 2 ys is equal to. Now, what about your right hand side? Like e to the minus t, just check the number 2, okay? Which is 1 over s plus s minus minus 1, which is 1 over s plus 1. Okay, and next step is obviously same. Okay, let me rewrite your left hand side without parentheses, and I'm going to plug in all the initial values in there, and it is s squared ys, and y0 is given by 0, which is 0, y prime is 1 minus 1. Let me distribute this one, okay, minus 2s ys, and y0 is 0 and it's gone, plus 2 ys equal to 1 over s plus 1, and we will do the same thing. Okay, here we go. Let me gather all the ys term. S squared minus 2s plus 2 is equal to 1 over s plus 1 plus 1 now. Okay, so we're almost there. Now we're going to divide by, like, hold this thing on your side, on both side. Then ys equal to 1 over s plus 1 s squared 2s plus 2 plus 1 over s squared minus 2s plus 2. Okay, and for here, let me show you how we can take care this guy. Okay, so like the second part, and we need one important skill. Okay, before doing that skill, let me split this one with two they use the partial fraction for this one, then this will be written by a over s plus 1 plus bs plus c over s squared minus 2s plus 2, right? And I believe you can do this one, okay? Then once you do that, it can be written by 1 over 5 over s plus 1 and plus minus 1/5 s plus 3 over 5 s squared minus 2s plus 2, and we have another one here, right? Then we can combine like this to right, that which is equal to 1/5. So let me write 1/5 in front, okay? It might be much better, right? 1/5 1 over s plus 1, and it will be negative 1/5 s, and plus 1, which is 5 over 5. It will be 8 over 5 s squared minus 2s plus 2, okay? So, okay, we are here, okay? We know about this, we are familiar with this, okay? That's exactly the table number 2, okay? But this one is a little bit tricky, okay? You have to take care of this one. Now let me show you how we can take care of this, okay? So denominator, like once you check the table, and there are lots of square form, which means we're going to try to make this one a square form, okay? What does that mean? This guy is equal to s squared minus 2s plus 1 plus 1, okay? Do you know why I'm doing like this way? Because we know this is perfect square, which is s minus 1 squared. Does it make sense? Okay, then this can be written by 1. Let me write the first term again, okay, because like we done that part already. plus negative 1 over 5 s plus 8 over 5 over s minus square plus 1, which is 1 square. Does it make sense? This is much more because like we can easily find this term like at number 9 and 10. Okay, so we can use both of them. Okay, so now we can split this one two part again as we did in the previous problem. Let me rewrite everything. Okay, it is 1/5 1 over s plus 1 plus negative 1 over 5s over s minus 1 square plus 1 square and plus 8 over 5 s minus 1 square plus 1 square. That's what I want to do. Okay, and now it's very last step. Okay, so let me write everything. Give me 1 second. I made a mistake. Okay, look at this guy. Okay, so when you compare this one with the table, oh, it must be number, not number 9, but it must be number 10. Oh, number 10 must have like s minus a, right? So like not this way, a little bit different. Okay, so let me change it. Okay, before writing this one, we have to do a little bit more about this guy. Okay, here we go. So like, this part can be written by this way. Your denominator is same, okay? But you must have s minus 5 on top, right? Which means you need like negative 5 over s plus 1/5, okay? Then since we take 1/5 like from 8 over 5, then we need 7 over 5 more. Does it make sense? Okay, then, okay, now I'm happy with that, okay? So that is equal to, let me rewrite, okay? 1/5 1 over s plus 1 and plus negative 1/5 s plus 1 over s 1 over 5 over s minus 1 square plus 1 square plus 7 over 5 and s minus 1 square plus 1 square. Okay, almost here. And that is equal to 1/5. We're going to take care of this one later, at the, like, all together. And minus, when you take out like this number, it will be s minus 1, s minus 1 squared plus 1 squared. That's perfect form. Then we're going to have like 7 over 5 here, and we're going to have 1 over s minus 1 squared plus 1 squared. Are you with me so far? Okay. Now, as I told you, let me state again. This is number 2 on the table, and this guy is exactly number 10 on the table, and this is number 9 on the table. Okay. So finally, my yt, which is inverse transform of ys, is equal to 1/5 times e to the minus t minus, okay, oh my goodness. Let me write a little bit behind of like the page number. Yt, which is equal to inverse transform of ys, is equal to 1/5 e to the minus t and minus 1/5, and it is e to the t and cosine t, and plus 7 over 5 with e to the t sine t. That's it. It was a little bit complicated, right? But like, with Laplace transform, we can do that.